In these questions, we're going to deal with a couple situations involving similar triangles. And I think that the hard part here is going to be just drawing these pictures, okay? After we draw the pictures, I think that the setting up all the math is a little bit easier, but um, let's see. We have Maritza, she's got a cottage and a shadow and all that stuff. So the first thing I want to do is draw the sun because there is a shadow involved. So this is going to be my sun, right? And then I'm going to make life easy on me here. I'm just going to draw a box that's going to represent her cottage. Now imagine the sun is shining down on her cottage and there's going to be a shadow, right? And the shadow is going to be kind of extending like this, okay? Now let's fill in everything that we know about this cottage. If we read through, we could see that the cottage's shadow is 48 feet long. So this line right here, which represents her shadow, is 48 feet long. I highlighted it in blue to make it a little bit clearer. So that's her shadow. And we do not know the height of the cottage. We'll make that orange. And that's what we're solving, right? We don't know what that is, so I'm going to call that X. Now it also says that Maritza is standing next to her cottage. So let's just put her, I don't know, right here, right? This is going to be Maritza. That's a really bad stick figure, but that's Maritza. And she's got a shadow as well. So assuming this shadow or the sun is shining down, she's gonna have a shadow that goes out as well. And let's run it out to there. And do we know how long her shadow is? Yeah, it says her shadow is 8 feet long. So that green line right here that goes out to about here is 8 feet. Now, as you can see, it's not in scale at all. This 8 does not match up well with that 48, but let's just roll with it for now. And it says that Maritza is standing at a height of 6 feet. So let's say Maritza right here. I'll make this a little bit more bold. That's going to be 6 feet. Okay. And I want to use similar triangles to solve. So I'm going to create a triangle here with Maritza. Okay. This is going to be a right angle, right? When she's standing down to the ground, that would create a right angle. And then I also want to finish up this triangle with the cottage. So I run a line going down this way. Now, for the sake of solving, we're going to say that these two triangles are going to be similar because they both have 90 degrees, and judging from the angle of the sun, let's just assume that this angle and this angle is going to be congruent, or they're going to be congruent. So by angle, we'll have two similar triangles, okay? Now my next step is going to set up a proportion. So I'm solving for x, so I'm going to start off with x. And I divide x by the side of the smaller triangle, which corresponds with the side that is x on the big triangle. So that's going to be 6. Again, to add to that, this big side here was x, and then the little side right here is 6. So that's going to be my first fraction. And then I want to use the other side of my big triangle, which was 48, that was known, divided by the little side, or I'm sorry, the other side that we did not use yet of the small triangle, which is 8. So there we go. So that's what I set up, and to solve for x, I'm going to cross multiply. So I take 8 multiplied by x, I get 8x. I take 6 multiplied by 48. I have 6 times 48. So 8x equals 6 times 48 is going to be 288. And my last step is just going to divide by 8, because 8 over 8 is 1. So you're left with 1x. And divide this right side by 8, and I'm left with my answer, which is 36, and that was in feet. And that represented the height of the cottage. Now, I'm just going to draw, just to make things a little bit easier, let me redo. These are going to be the two triangles that we worked with. I know that this might not be that clear, but the values were x here, and this was 48, and then this was 6, and this was 8, and we said that this right angle is going to correspond with this right angle, and this angle here is going to correspond with this one. So this is what we had was angle, angle. That was the similarity statement. I'm sorry, the reason why these two triangles were similar. That wasn't the similarity statement. Okay, in this example, we have another situation with some shadows. So I'm going to go ahead and draw a sun in here. And I'm going to draw the ground. And we have a post, right? So there's my post. And there's going to be a shadow from the post. So let's just say my green line here is the shadow of the post. And we also have someone named Jack. He's going to be standing 7 meters in front of the post. So let's put him at, I don't know, right about here. Okay, there's Jack. And what we said, 7 meters in front of the post. So from this point to his feet right here, that's going to be 7 meters. And he also has a shadow. So from Jack going this way, there's a shadow. And it says his shadow was 1.8. And again, this is not to scale. We just got to draw it so we get some triangles. So speaking of triangles, let's go ahead and draw in a line. This would be like the ray of sunshine almost, right? Down this way. And we'll get some triangles created here. If you take Jack, run a line right through him, that's going to create a 90-degree angle right there. And you've got this small triangle, right? Well, the post hitting the ground, that's going to be a 90-degree angle, right? And just for the sake of solving this problem, we'll say that this small triangle here, which is created with Jack, is going to be similar to this huge triangle right here created with the post. So that angle and this angle would be congruent, and then we could say that this angle right here is shared with the small triangle and this big one that was made. Now, what do we have to solve for? Well, we don't know the height of the post, so I'm going to put x next to that and then set up a couple of fractions to make a proportion. So I need x, so I start with x and I divide that by the side of the smaller triangle that it corresponds with. So this side of the big triangle matches up with this side of the smaller triangle, and that would be the height of Jack, which we didn't label, so let me put that in there. That was set in the problem. So x divided by 1.3 is the first fraction, which will be set equal to. We need to come up with another fraction. So we need one of the sides of the big triangle. We already used this side, which was x. So let's use this bottom part. And we know that the first section right here we have 7. And in the second section we have this little part right here, 1.8. So we could add these together. That's going to give us 8.8, and that's going to be from this point here all the way back to the post, 8.8 meters. So that goes in the top, and then we divide it by the side of the smaller triangle that it corresponds with. So the bottom part of the smaller triangle is just this little section, 1.8. And again, if you're looking, be like, wow, 7 and 1.8, that looks like they're the same lengths. Well, it's not to scale. So let's just roll the triangles. Next step is to cross multiply. So I've got 1.8 times x. So I'll do that. And then I've got 1.3 times 8.8. That's going to be 11.44. To get x by itself, I want to divide both sides by 1.8. And I'm left with x, because 1.8 divided by 1.8 is just 1x. So here's my 1x equals, and 11.44 divided by 1.8 is 6.35, but the 5 goes on forever, so I'm going to write a line over the 5 that's repeating. So what was this unit? It was meters, right? So I'm going to say that the height of the post was about 6.35 meters tall.